Project title: IoT Data Collection and Dashboard using Node Red. Course: DFI 10472 Introduction to Internet of Things. Group name: Virus EXE Group. Team members: this project is presented by Juan Mohammed Hakimi Daniak bin Juan Mohammed Saifuldin, Student ID, DFI 2601015, and Mohammed Azimi bin Zafral, Student ID, DFI 2601011.
The primary objective of this project is to develop a robust Internet of Things (IoT) system capable of gathering essential environmental data and visualizing it through an interactive dashboard. By utilizing the Node Red platform, the system effectively collects real-time readings for temperature, humidity, atmospheric pressure, and altitude via the MQTT protocol. This development process provided significant experience in managing MQTT data streams and configuring Node Red workflows to create a clean, user-friendly. To ensure the successful completion of the project, tasks were strategically distributed between the team members to leverage specific technical strengths. Juan Hakimi Daniel bin Juan Mohammed Saifuldin was responsible for the web UI configuration of the temperature and humidity sensors, as well as the production of the project's video presentation. Meanwhile, Juan Hakimi Daniel bin Juan Mohammed Saifuldin focused on the web UI configuration for pressure and altitude sensors along with the detailed report analysis. The project was executed following a structured timeline, with the core development and configuration taking place around April 22, 2026. During this phase, the Virus EXE group focused on setting up the necessary infrastructure, including the MQTT broker connection and the initial logic flows within Node Red. Careful planning was essential to ensure that each sensor node was correctly identified and that the data transmission frequency was optimized for real-time monitoring. This preparation The backbone of this IoT system is the Node Red flow configuration, which starts with an MQTT input node connected to the MQX.io broker. Once the connection is established, the data is channeled through various change nodes labeled for specific parameters such as temperature by Hakimi and pressure by Juan Hakimi. These nodes are critical for processing the incoming data packets before they are sent to the output UI elements. The flow is designed to branch out into multiple visualization nodes, including charts, gauge. A deeper look into the flow configuration reveals the use of specialized nodes to enhance the user experience and data accuracy. For instance, a dedicated CSS node was integrated to style the virus text elements, providing a customized aesthetic for the dashboard interface. Each sensor path is meticulously mapped to ensure that variables like humidity and altitude are routed to their respective charts and gauges without interference. This technical setup demonstrates the versatility of Node Red in handling diverse data.
The dashboard design focuses on clarity and immediate data interpretation through high-contrast visual elements. Temperature and pressure are prominently displayed using gauges with color-coded zones to indicate safe or critical levels, while battery and tank levels are visualized using progress bars for quick status checks. Real-time line charts are positioned below the gauges to track historical trends, allowing users to observe fluctuations in environmental data over time. This layout ensures. During the testing phase, a significant challenge arose where the dashboard visualizations remained inactive despite the flow being deployed. Upon investigation, it was discovered that the sensor values were incorrectly assigned to flow.payload instead of message payload within the change node. This was a critical error because Node Red dashboard elements are designed to trigger specifically from the message object to receive and display data. By reconfiguring the nodes to target message payload, this project provided a valuable learning experience regarding the technical distinction between flow context and message payloads in Node Red. The troubleshooting process highlighted how data can become trapped within internal memory if it is not correctly routed through the message object. Resolving these configuration errors improved my understanding of how to build reliable IoT communication streams and interactive dashboards. Furthermore, the project underscored the importance of meticulous debugging and, in conclusion, the IoT sensor dashboard was successfully deployed following the identification and correction of key configuration errors. By ensuring that data from parameters like pressure and altitude were assigned to the correct message payload, the system achieved full functionality for real-time monitoring. This project successfully demonstrated the integration of MQTT protocols with Node Red to create an effective environmental monitoring solution. Ultimately, the experience gained